Hi, and welcome to another session of the IaC Podcast, and we have one of the best experts in the field, Derek Morgan. Hi, Derek, great seeing you.
Ohad, it's always a pleasure. Happy to see you as well on such a busy KubeCon.
Busy KubeCon, so it's not your first KubeCon, right?
It is not. This is my third American, and I had one in Valencia as well.
Got it. And what do you see in this KubeCon compared to the previous ones?
AI, a lot of AI.
Yeah.
But I love seeing and hearing all about OpenTofu.
OpenTofu, yeah, we had OpenTofu Day a few days ago. Were you watching it?
Unfortunately, I did not make it. I was still very tired from the plane.
Yeah, I heard you woke up very early.
About 4 a.m. and flew straight in, and I immediately kind of zoned out for the day.
That's right. Let's talk about infrastructure as good. You see a lot of practitioners trying to get things done. What are your thoughts? What's happening? Maybe even specifically about OpenTofu and the latest release as well. What do you think is happening recently?
OpenTofu is building a lot of the features that people have been asking for forever. Terraform.
Such as?
What did you just do with? Did you just add variables to, what was it? Variables in the backend?
Mm-hmm.
Was it variables in the backend? I'm trying to remember the latest feature.
We had the for each for providers.
For each for providers, right? That's a new one.
State encryption.
Yep. State encryption at rest, and yeah.
Cool. And back to Kubernetes. Maybe this is KubeCon and Kubernetes.
Sure.
Do you feel that Kubernetes is mature in a way that's going to be enough innovation going forward? Or you think all of the major innovation already happened?
I think everything I've been seeing is just still improving Kubernetes and fixing things that have been, issues that have been around since the beginning.
Yeah.
I haven't really seen any features on top of Kubernetes that blow me away.
Okay.
Most everything you're seeing is observability and how to fix things that have been around forever. So that's kind of what I'm seeing with Kubernetes. And then, of course, again, AI stuff everywhere, nonstop.
And if we talk about Kubernetes and Terraform, what we see very often is that most of the code that's eventually being executed runs somewhere in a Kubernetes cluster.
Yep.
More and more things, the default compute becomes, instead of virtual machines, becomes Kubernetes and Docker containers.
Yes.
So a lot of the updates to the infrastructure, what is the infrastructure? Is the infrastructure the entire cloud, or the infrastructure is that just the Kubernetes cluster itself?
Well, I see a lot, I actually still see people having to integrate Ansible with Terraform just to bootstrap these Kubernetes clusters, because you still have a VM.
Yeah.
It's not serverless. You still have things to configure. You have daemon sets to deploy. You have all sorts of extra stuff that needs to be in place to ensure monitoring and observability works. So you still have that infrastructure feel to Kubernetes. It still kind of almost feels legacy some days. But, I'm hoping things get a little smoother, but it does still seem like there's a lot of moving parts, and it requires a lot to get right.
And if we meet again here in 3 years, 5 years, what do you think would be the number one difference between now and the future?
I really don't want to say it, but I'm going to say it. I think you're going to see a lot more natural language going on.
Yeah.
You're going to see...
Why you don't want to say it?
Because everybody says it. Everybody says it.
You want to say something special.
Yep, but it really is. I'm pretty bullish on the idea that we're going to see a lot more just, I need this, and it's going to happen.
Yeah, makes sense. All right, Derek.
All right.
Thanks for coming.
Absolutely. Cheers. Thank you.
Hi, everybody. Welcome to another quick session of the IaC Podcast, and we have an amazing guest, Solomon. Solomon, tell us about your background.
Hi, I'm the co-founder of Dagger.io, and before that I was the founder of Docker.
Yeah, so we're here at KubeCon, Kubernetes, and Kubernetes runs Docker containers, so maybe you're kind of the host of this entire event, kind of.
Yeah, I've been hanging out in container land for a while.
So tell us more about what you think has evolved, with compute from virtual machines to containers to Docker and to Kubernetes, or maybe.
Yeah.
I always thought about, maybe you're not the best person to ask that, but Docker Swarm versus Kubernetes, and now we're at KubeCon. So maybe you want to say a few things about, clusters of Docker containers.
Yeah. Well, with Docker, our focus was just getting the world to adopt containers as a whole, as a platform.
And you've done an amazing job with that.
Yeah, it did work. It took a while, but and so orchestrating containers in the data center was one piece of the puzzle for us. You know, we had to worry about every aspect of the compute landscape changing overnight. So we had to worry about the developer experience, networking, storage, logging, security. Everyone had to containerize.
Yep.
And so containerizing the scheduling of jobs in a cluster, which is what Kubernetes does.
Yep.
For us, that was one piece of the puzzle. So yeah, we had 50 projects at the time competing to be the one and only way to schedule those containerized tasks in a cluster. Kubernetes was number 20 or 25 in the list.
Wow.
It was just very messy and chaotic. This is 2014.
When was that?
2014.
2014.
Yeah, so 10 years ago. And so
when it just started, yeah.
We were trying to just get the whole platform to come together.
Yep.
You know, these days you have the huge CNCF landscape with 1,000 logos, but back then there were none of those logos. We were trying to create those logos.
Yep.
So we just had to make quick decisions on each. So yeah, at some point, we built that, Docker Swarm as an in-house version.
I've used Docker Swarm.
Yeah, it's still out there.
Yep.
But you know, like there was a build in-house or let the ecosystem build it decision everywhere around us. It was like 50 decisions to make. Yeah.
Absolutely. Okay, so fast forward to Dagger. What is Dagger and what?
Dagger, yeah. So Dagger is my
second
second startup. It's a programmable pipeline engine. So it the same way Docker containerized the application, Dagger containerizes the pipeline.
The CI?
Yeah, the CI. So test, deploy, build, and it turns out those pipelines just have the same problems today that the application had 10 years ago. You know, it doesn't run the same locally and on the CI server. It's not portable across CI server.
Yeah, I just use Jenkins and I need to run things at the Jenkins server.
Right, exactly. So that's...
And things are either different or impossible to be executed on my laptop.
A whole lot of logic that is super important for shipping your app is trapped in that one CI server when it should be free to run on this server or that server or my laptop or a whole cluster. So it's the same problem of containerization just applied to the pipeline. That's what Dagger is.
It sounds like you're always thinking about the developer experience, doing things in a standard way that work everywhere the same way.
Yeah, it's super important, and it's what we started with Docker, but I don't think we're done.
Of course. And what do you think is going to be with Kubernetes? Not 10 years since it started, but 20 years. Let's say if we meet here again in 10 years, what do you expect to happen?
For Kubernetes?
For Kubernetes, yeah. Or maybe the CNCF as well.
Yeah, I don't know about the CNCF. I think Kubernetes is very stable, very mature.
Yeah.
So it has many years ahead of maintenance and improvements. You know, it should be more scalable, more secure, more stable. I don't think it'll be that different in 10 years. I think it'll be the same, just better.
Just better.
Yeah.
And what about the entire ecosystem of solutions? Because from my point of view, if I look backwards 10 years ago, the default compute was virtual machines. And today the default compute, if you need some Java code to run somewhere, it's going to be very weird for you to provision a virtual machine in a JVM and then run the Java code. You're probably going to use a slim Docker container that only does that, and you're probably going to manage that with the Kubernetes cluster. So
maybe. I don't know. I think the container standard is much bigger than one implementation. So yeah, I think maybe you'll run that container in Kubernetes, maybe not.
All right, that's very insightful. So thank you so much for sharing your thoughts about the space, and I really appreciate it.
Yeah, my pleasure.
Hi, welcome to another session of the IaC Podcast, and today I'm here with Rotem from Ariga. Hi, Rotem.
Hey, good to meet you.
So tell us about Ariga. What's going on in Ariga?
So Ariga, we started the company something like 4 years ago. We are building a tool named Atlas. Atlas lets you manage your database schema as code. It's been called by our users kind of like a Terraform for databases.
Terraform for data. So let's say I'm a DBA, and I have a MySQL or Postgres database.
Yeah, sure.
Okay, so I have Postgres. whether it's, let's say, RDS in AWS. Okay, so I have all of the different definitions that
Sure.
I need to manage and have, I don't know, versioning and audit.
Exactly.
So how do I handle that challenge?
So the reason we need tools to manage schemas is because software is never done. And when we are building backend applications, they are typically backed by some database. Specifically at Ariga, we're focusing today on relational databases, but some of this applies also to NoSQL. And when you change the data model of your application, let's say you're building a content management system, now you're adding, I don't know, a biography column to the user entity. Then before you deploy that version of your application, you have to update the database, because otherwise the backend will issue queries to the database and the database doesn't know what you're talking about.
Of
So
course.
you have downtime. So this is why we have database schema management software. Now, typically the way it's been done, many years ago, you had a DBA. You open a Jira ticket or whatever, ask the database team to create this column before you deploy. Then we had a generation of what is called schema migration software, where you write the SQL script, but it's an imperative operation. Like you give the instruction to the database, create this index or add this column to this table. And that was pretty much the case for the past 15, 20 years. And when we started the company, we noticed this huge gap between all of the amazing stuff we experienced as infra engineers around tools like Kubernetes and Terraform, where we could say, okay, we just want the system to look like this, and have the tool automatically figure out the right way to get there. So we wanted to really build that out for the database schema management process.
So for example, in Terraform, I can execute Terraform plan and not to actually update the infrastructure, but to simulate what's going to happen if I am to approve that change. So do you have the same kind of concepts?
Exactly. So within Atlas, we have two kinds of workflows. One is more similar to the classic approach, where Atlas outputs a SQL file that you can apply later. So you kind of get this offline plan, but automatic planning. But we think this is kind of an interim solution. It's because the industry is used to this solution, but we want to help with automatic planning. What we're actually going for is full declarative migration, but still people are not going to easily trust a tool with touching their database. So what we build this process is where you change the schema, your desired schema in code, you create a pull request, then we generate a plan like a Terraform plan. You get on the pull request, this is what I'm going to do. And then also we have a migration analysis engine. So it's like designed to surface risk. This is a destructive change, it will delete data. You're using Postgres, if you add this index not concurrently, it's going to lock the table and you'll have downtime. So we give the user feedback on what they should do if they don't want to mess up their production. The user has a mechanism to edit this plan as part of the pull request process. It gets approved. We have a component called schema registry. So you can store all the approved plans in some layer that is aware what is allowed, what is not allowed. And during the deployment, basically Atlas will only move forward if it has a plan that a human approved based on policy during the pull request phase.
And from your experience, where do you see most databases exist? I assume it's outside of the Kubernetes cluster, but am I wrong?
So I was here in 2017 in KubeCon. Kelsey Hightower went on stage and he said pretty much, don't use databases inside Kubernetes, put them out. And I think, what's that, like 7 years ago, that was pretty much the case. We didn't have the good machinery to run databases on Kubernetes, so most teams that I know put an RDS instance in the same VPC, but we didn't have the tools to run it on Kubernetes. But I think something very cool that we see happening in the Kubernetes ecosystem is the creation of operators. So basically custom, we create CRDs and we have a controller, some specialized program that can reconcile the state. And once we have that, and people build the SDKs to make it easy to build them, then maybe it's not so scary to deploy a database to Kubernetes because you have a lot of expertise baked in and codified into the operator. So I'm hearing this more and more from our users. We hear from the questions they ask that it does exist in the wild, but I don't have like a Gartner number on how many people do it, but it's actually happening around us.
That's interesting. So Kubernetes is transitioning from compute only to more than that, such as persistent databases.
Yeah, there was data on Kubernetes Day yesterday, and one of the lecturers was about exactly this problem. The demo, I didn't know about it, but the demo was how do we provision the Postgres instance with a Postgres operator, and then we manage the schema with Atlas. So kind of two operators that mix together to give you a declarative approach.
That's interesting. And besides like rational or relational databases, what are your thoughts about other types of databases?
So it really depends on the databases. And with SQL, we are lucky to have ANSI SQL that kind of creates there's still differences between the engines, but it's very similar. So for us to create an abstraction API, it was a very easy solution to start building the startup around relational databases. But I had a lot of pain in my career working with large Elasticsearch clusters and managing indexes that I wish I had something like Atlas to manage them. I did this with Scylla and Cassandra. There's also a schema. Some databases are really like document-oriented or key-value-oriented, where the schema really exists in the application layer. In there, I don't know if there's anything that you can do, but as far as the database allows you to define some shape to the data, you definitely see Atlas expanding into that.
That's awesome. So good luck with that, and congratulations on all of the success so far.
Thank you.
Thanks for coming today.
Have a good time.
Hi, so we're here for another session of the IaC Podcast, and we're here with Marc from Tremolo Security. Hi, Marc.
Hi, how you doing? Thanks for having me.
Yeah, tell us about the company.
So we do identity management. So you got your apps want to know who you are, what you can do. The auditors want to know why. So we give you an easy open source way to be able to onboard applications. We're probably best known for our Kubernetes integration. So whether you're running on-prem, in the cloud, gives you a one-stop shop to get access to all your clusters.
Got it. So let's say I'm managing the Kubernetes clusters and I start to have some challenges at scale. That's where I start approaching to you and try to understand how do I solve these challenges?
Yeah, exactly. So
if I have just a couple of clusters, I'm probably still not in a need for that solution, or not necessarily?
No, even with a couple of clusters, because the thing is that it's getting more and more expensive to run individual clusters.
Yep.
It's not just the cost of the API servers, it's the cost of the people, the resources, the know-how, and so multi-tenancy is just a lot easier way to manage that. So where our customers tend to come to us and say, okay, we need to carve up this cluster. We want to do it in a way that is consistent, it's repeatable, and it works with the other systems that we need to plug into. Because Kubernetes is great, but you need to plug it into Git. You need to plug it into monitoring. You need to plug it into all these different systems, and those all have their own authentication.
Yep.
Those all have their own role-based management.
Yep.
So we bridge that gap and we make it all look like one simple system.
Got it. And if we go wider than Kubernetes, because it sounds like you said that you are most famous with your Kubernetes integration, how do you explain that? Like if I have, I need to monitor my EC2 instances as well, my virtual machines, I need to monitor my storage, my databases. It sounds like what you're describing is that it's more repeatable maybe with the Kubernetes use case. Why is that?
So we actually got into Kubernetes more because it was a nice niche for us.
Yep.
And I personally have always had a love of infrastructure. So even in my earlier days when I was doing management consulting, I tended to gravitate towards large projects that were the identity around infrastructure. So migrating these massive implementations across vendors for these Fortune 100 companies in the identity space. So then when we started Tremolo, crowded space, there are a lot of identity management companies, and because I really liked Kubernetes and I always had a love of infrastructure, it became a niche for us.
Interesting. And speaking of Fortune 100 and Kubernetes, from your experience, where do you see most of the Kubernetes clusters running in these bigger organizations? Is it one of the public clouds like EKS or GKE, or is it more like on-prem?
Yes.
Yes, what?
Yes,
On-prem?
all of it,
all
right?
Of it?
Like, every customer I have has on-prem, has at least 2 public clouds, maybe 3 public clouds, has some combination of some smaller, more specialized providers. Like, it's all over, right? Like, Kubernetes is not cool anymore, right? Like, it's everywhere.
Yeah, it's
So
commodity.
It's a commodity, and so, but still a very complicated commodity.
Very much.
So knowing how to manage that, being able to centralize it, and there's a big difference between someone who knows enough about Kubernetes to write some YAML, some deployment manifests, stuff like that, and someone who knows how to debug a broken cluster.
Yeah.
Like, those are 2 very different skill
skills.
sets. So most of the app teams, they got plenty of folks that can write YAML. Like, that's reasonable to ask them to do. Ask them to fix a broken cluster, and they're,
Where do I
now
start?
what?
Yeah.
And so what you're seeing is, especially in the large organizations, a centralization of Kubernetes skills. Where they're saying, all right, we're going to take the couple of dozen people that we have that really know Kubernetes, and we're going to create a center of excellence, just like every other technology, right? Like, every team doesn't maintain their own DBA. Every team does not maintain their own, email admin. It's all gets centralized. It's all special interest. And so that's what I'm seeing now is, as we go to different customers, they're saying, all right, we used to hand out clusters, but we don't want to do that anymore because our app teams don't have people that can fix them, and we don't want to spend all our time running around putting out fires.
Got it. And now Kubernetes is celebrating 10 years, and sounds like you see a lot of Kubernetes clusters in action. Where do you think Kubernetes is going to be 5 years from now or 10 years from now?
I think it's going to be a little bit easier, but it's ultimately solving a really hard problem. And I don't think it's fair to say we should make complex problems all solved with easy tools, right? Like, if this was really easy, everyone would do it.
Correct.
Where I think Kubernetes is going to get really exciting in the next few years is a move away from just doing containers, right? Like, you're starting to see it with VMs, with KubeVirt.
Yeah.
There was some talk a few years ago, I think it made one of the keynotes at KubeCon a few years ago, this idea of using the Kubernetes API for the data center, like turning it into the data center API, because it's relatively simple. Like, as APIs go, it's relatively simple. It's got a very nice authentication authorization framework that they're making much nicer. It's pluggable, right? Like, think about where Kubernetes is. Didn't they just eliminate like all the in-tree stuff for the individual cloud providers this year? So you're now at a point where you don't have any custom code for the cloud providers anymore, right? Like, that's all out of tree. That means you can extend the heck out of that system. So I think what you're going to find over the next several years is, in addition to growing the container space, you're going to start to see Kubernetes becoming the API for the data center, yeah.
All right, that's very interesting. Thank you so much for,
Thanks for having
sharing
me.
those thoughts with us. Thank you. Hi everybody, welcome to another session of the IaC Podcast, and today we have Eldad from JFrog. Hi Eldad, how are you?
Hi, nice to meet you, nice to meet you.
Tell us about JFrog.
Well, JFrog, I assume everyone knows about JFrog, and if they don't, they should look up. JFrog delivers a platform for managing packages, any type of package you could think of, and on top of that, we have a whole solution around security, all the way from developer environment, CI/CD, and also in runtime, we've just announced a runtime solution. So this is kind of a JFrog in a really small nutshell.
So when you talk about packages, there are the more application layer packages, and there are more the infrastructure layer packages. In our world of infrastructure as code, we often see the module registry, for example, where you manage your packaged, predefined code that others can use.
Yes.
From your experience, do you see customers more and more using infrastructure as code, and how do they manage their modules?
Yeah, so infrastructure as code has become the de facto standard. I mean, if you're not there, then you're really missing out on something.
Why is that?
Because everything is code. Everything should be managed. Unlike I can
Like,
go back.
like JFrog, you have your own Terraform provider, right? Instead of
Exactly.
clicking buttons in the JFrog
Yes,
UI,
yes.
I can just write code that represents my configuration and manage
Completely.
it in version control.
Completely. We have customers that actually use either Terraform or OpenTofu to set up the whole infrastructure and install JFrog on top of it and configure JFrog itself, all with configuration. No manual work, no lines of code, pure configuration is code. We
Yep.
actually have a few examples out there you can find. And we saw more and more customers just ask for it because they were saying, wait, we're managing our Java packages, Maven, we're
Yep.
managing our NPM packages,
Yep.
we're managing our container images.
What about Terraform?
Exactly, why shouldn't we manage our Terraform modules the same way?
Yep.
So we delivered. And
Awesome.
Artifactory supports that, including scanning of the modules themselves.
Yeah,
so
yeah.
you
So
can get
if I have
scanning.
some issues in my modules,
Yeah.
can you X-ray my?
Yes.
You saw that? You
Yes,
saw what
yes,
I did?
yes.
What I did just
Pun
there?
intended. Yeah, so yes,
Can
we
I
have
X-ray what's going on there?
we have JFrog X-ray, which scans also the infrastructure as code modules, looks for vulnerabilities, also suggests some remediations.
So you think it's not a good idea that my Terraform code provisions maybe EC2 instances with SSH open with empty password? That's not a
Probably
good
not.
good best practice.
Probably not, unless you like to live
Good
on the
practice.
edge and you're looking for some
I'm
excitement.
looking for that. Yeah. So will you X-ray that silly definition of SSH, for example, and
Yeah.
warn me about it?
Yes, you'll get a warning about it.
So that's more
and
governance
including-
for me to know that the
Exactly.
risk is decreased.
Exactly. It allows you to really have good control of what's going on in the organization, apply some policies. You can block malicious behavior or potentially malicious behavior, and of course vulnerabilities. So we provide this end-to-end one-stop shop for managing the modules, scanning them, and giving you ease of mind when it comes to managing all of your infrastructure as code.
Great, and I saw that you officially added support not just for Terraform but for OpenTofu as well. So
Yes,
that's
of course.
congratulations.
Well, we got this again. The community is asking for it. We're trying to be as open-minded and as insightful with the community as we can. So we added that recently.
And what do you think is going to happen with the scale of infrastructure as code in the next 2 years?
Everything is booming. I mean, everyone wants infrastructure, public cloud, self-hosted, of course, Kubernetes. And the more complex it gets, the bigger it gets, the more control you need to have over it. And we actually see a trend of more and more customers using infrastructure as code to manage their deployments, to manage their configurations, to manage their whole infrastructure. We do it ourselves. JFrog has a huge presence in cloud providers. We have GCP, AWS, Azure deployments of the JFrog platform, and it is all
May I
managed.
ask, how do you manage all of these deployments?
We use Terraform with env0.
Ah, cool.
And it works. It just
Nice.
works. We have our own Git repositories with all the configuration. It's all managed modules inside Artifactory, and it's completely automated, completely hands-free. And just like you'd expect, we need a change. We need to add a security group. We need to add a new database instance in a region. We need to spin up a new region. Our developers, our cloud engineering developers will just set up the configuration, create a pull request, review, merge, and it works.
That's it. Sounds great. So it looks like the world is ready to scale infrastructure as code.
Completely.
and-
Infrastructure and code, GitOps,
and less
everything.
click ops.
Well, yes, definitely. I mean, everyone who's everyone knows where the world is going,
Yep.
knows what are the right things to do. Some organizations are still struggling with the implementation, but the trend is clear.
That's awesome.
It's evident that everyone's going that
Cloud
way.
is
We
becoming
can.
code.
Completely.
Great.
Completely.
Thank you so much, Eldad, for being today.
Thank you for
Pleasure.
having me. Thanks.
Hi, and welcome to another session of the IaC Podcast. And today we have Andy Martin from ControlPlane. Hi, Andy. Thanks for coming.
By all means.
Please introduce yourself, Andy.
Hi, well, I'm Andy, founder and CEO at ControlPlane. We're a cloud-native security consultancy, and we assure critical platforms for regulated industries, tier one banks, governments, and penetration testing, build out. Everything is just very good DevOps with security as criteria.
Cool. So I think a thing or two about open source and about the CNCF. Is that right
yes,
to say?
I've contributed to the community for a little while, yes.
So what do you do in the CNCF?
I currently have changed one position. So I was working in tag security as one of 3 co-chairs to help assure the project's going through graduation.
Yep.
So at the point the project comes to graduate, to receive the benefits of the budget that goes with that and all the CNCF supports, they must go through the security audit. And that is us looking at how is the usability of this from a security perspective? Is the documentation up to standard? Have you considered what the supply chain going into this product and any side effects, what you consume? And then we collaboratively develop a threat model or some form of governance documentation for the project that we can then take back to the TOC and say, this project cares about security, they've implemented these features, and for these risks, they have them mitigated in a different way.
Okay, so we're focused on infrastructure as code here at NF0, and one of the biggest concepts that helps our customers with security is policy as code.
Yes.
So let's zoom in and let's talk about a specific project within the CNCF, OPA, the Open Policy Agent. From your experience, what have you seen in the past few years that has happened with the users of OPA, for example?
OPA is very interesting because, of course, the Styra guys who put it together in the first place, this is their 3rd authorization system they've built. So they built Rego, and they created a language where the return code of an assignment has an effect on whether the program stops or not. That level of complexity has made adoption a little bit difficult, so pre-configured packs have been the way to do this. You can extend them. I would have liked to have seen things like the proposal for SIG-store validation within Rego land in main, because that would then give you a full suite of admission control. But as it stands, having policy as code that you can threat model, you can quantify the risk and whether or not this is blocking one or multiple branches of an attack tree, the adoption still is increasing and it's still the best tool for the job. I mean, Kubernetes does a good opinionated alternative by essentially removing a lot of the configuration and giving you sort of more opinion, let's say. So yeah, I mean, OPA is wonderful, policy is code everywhere. Of course, static analysis on the infrastructure is code before you get there. And again, that sort of, and we have Gareth Rushgrove to thank for the tooling to actually run those OPA tests locally. So yeah, big fan, have been for a long time.
And you've talked earlier about the help of CNCF making the project more mature. If I remember correctly, OPA is a graduated CNCF project, is that correct? Or is it still incubating?
You have got me there, I don't know.
But what does
I'd like to guess yes, because it was an early project, but I don't know.
So how do you guide these projects in order to become graduated projects?
So for OPA specifically, I didn't work on that if it came through tag security.
Sure.
I guess tag security is probably about 6 or 7 years old. And I've been contributing for about 4 years, I guess.
All right.
But in terms of, so for that project, when it comes through, then, and that's an interesting one because we would be interested in, is the language designed in a secure by default way? Well, it's a policy language, so you're probably okay. It's also reasonably tightly scoped. It's not Turing complete. I don't think it is. And also it's in production, so you're probably not going to be able to convince the team to, if I had a feature request, which I do, that's not the right level and not the appropriate thing to do in that community assurance piece. A useful thing that we do is when you install this as an admission controller, then it fails open if this is not checked. So perhaps a secure by default modification to the way that you give this to your customers, and I'm making that up incidentally, that's no shade thrown. That's the kind of thing that we'd say, well, in order to make this easier to adopt and reduce the risk of misconfiguration, maybe X, Y, Z. We'd also be interested in how their admission controllers are built, but of course OPA, because it's almost like removing the HCL from tofu. Kind of 2 separate parts. So that would be a tricky one, but yes, that kind of level.
And for last question, you've been to 1 or 2 KubeCons in the past. What do you think is going to happen with KubeCon and maybe Kubernetes in general if we meet again in 3 or 5 years?
Well, I'm sure we will meet again in 3 or 5 years because the community has grown, learned all the lessons from OpenStack. We have this massive attendance and it's now transitioning into the uncanny valley. We've been through the phase where all the hype cycles kicked off. now it's easy to forget, especially with the kind of customers that I work with, that they've probably only got 5% of their compute base with Kubernetes on. They're using a bit of Kubernetes, but these are, telcos are maybe 10-year cycles, banks maybe a little less, but the time to deploy this infrastructure, the time to get eBPF on a kernel, like a mainline 510 now, it's still stuff that's still on 3 or 2 series kernels that's not going to get touched in these big organizations. So the momentum is there. From a security perspective, Cloud Native SecurityCon and the OpenSSF pieces, they're continuing to grow, and there will be a new form of those next year with the Open Source Security Conference, which brings both of those Cloud Native plus sort of infrastructure level security together. Of course, the next KubeCon's London. We run the CTF here, and in room 255, if you fancy a go. So, where do we see it in 3 to 5 years? The community is established enough that it's on a platform to just continue to accelerate that gradient. I think adoption is there, the community is there,
Absolutely.
The software's good, the onboarding is good. I'm also duty-bound to say this because I run a Kubernetes consultancy. But nevertheless, as it continues to adapt and be everything to all men, from telcos through to microservices and everything in between, and modern AI compute workloads, the flexibility inherent in the original API design specification and extensibility will mean that it's going to be very difficult to challenge, I think.
Sounds good. All right, thank you so much for
Yeah,
sharing your thoughts
thank
today.
you.
Hi everybody, welcome for another session of the IaC Podcast, and today we have Miguel from Elastic. Hi Miguel.
How's it going?
Great. So tell us about yourself and what do you do?
I'm a product manager for Elastic, working for Elastic. I work specifically in the cloud native area, most specifically with observability of Kubernetes. So that involves also OpenTelemetry, Prometheus, anything that kind of like falls into the area of the CNCF.
Got it. So let's say I'm using Kubernetes.
Yeah.
Okay. I know some people use Kubernetes. I've heard of these people.
Should we have some of the folks around here?
And let's say my applications start to be slow. Okay. And I want to understand what's going on. So where should I start?
So I would say, like, first of all is you need to abstract all the complexity and start right at the top. So for me, like if we're talking about applications, I like to take this approach that is a holistic approach, where if you're looking at a system, you want to abstract all the complexity and start with SLOs.
Yep.
Because SLOs are the top layer where they're going to tell you something is happening. Because they may be that especially when we have Kubernetes that is a self-healing technology, you don't want to be like overwhelmed with all the noise, that things that went broke, then it got fixed. Do you really want to be woken up at 3 a.m. because a pod crashed and then one of the controllers was able to get it back running? Yeah, maybe you don't. But if you wake up at 6 a.m. and everything is back and it's running and your SLOs are fine and you don't got anyone that was trying to access your application from the other side of the world pinging you, then you're fine, just stay in bed, basically.
So let's zoom in on OpenTelemetry. This project has gained massive success in the past few years. What do you think is the number one reason that OpenTelemetry increased its usage so much?
So the interesting part is that when you're instrumenting applications, it's painful. People, they don't want to be switching instrumentation every time that they switch vendors. So it makes sense for the instrumentation to be vendor agnostic. So to have mechanisms like the instrumentations that OTel is giving for each language, also the collector, which helps users to capture and also manage and send out the data. So it makes sense for that stuff to be vendor agnostic. But one important bit that OpenTelemetry brings to the table, because there are many collection mechanisms. We have bits, for example, you have FluentBit, there are many of them. One important, secret ingredient that I like, it's not secret, but is the data model. So you have, on top of this, you also have semantic conventions. So that means that you and I are aligning in what we are calling a signal. So what we call a Kubernetes memory usage is going to be the same regardless of what vendor you use. So that means that we collect this signal, we send it to a backend, which is the way that we call vendors in the hotel world, and that backend is going to understand it straight away. And that also means that your data, you are understanding the data that you collected, you're able to see it in the backend. And if you want to create custom visualizations, you want to do something, is that the same data is throughout the same data, so you're able to do that. The other aspect is resource attributes. So resource attributes are a way that we give special treatment to metadata that is important to tell us that these are resources. So these are the things that are actually emitting the telemetry. So when you have a log and you are attaching to it metadata like, okay, we're attaching the Kubernetes version, the Kubernetes cluster name, the pod, should we all treat that as the same? No, like version probably like, is that telling you where the telemetry is coming from? No, but if you have Kubernetes pod.pod.name or case.pod.name like semantic conventions say, and as a resource attribute, that will enable us to enrich logs, metrics, and traces in the same way, and then eventually correlate logs, metrics, and traces with the same semantic conventions and with the same resource attributes.
Got it. So, after the application is running day 2 operations, we already have the ability to see the traces, to see the telemetry, to understand what's going on and maybe what's going on in a bad way and to analyze it. But if we shift left, and now I'm going to create a new service that's going to run in Kubernetes, can you give me a good idea on how many resources, how should I think about how many resources I need to allocate for my new service? What should be like the checklist of the things I need to think about before adding a new service?
So first of all, this is kind of like dialing back similar to the SLO's conversation where you got to understand what is the service level that your customers are expecting.
Yeah.
So it's very different if you tell me, you know what, I need an application that is going to service 10 users. It's very different that when you tell me like, no, I need an application that is going to service 100,000 users. So let's say you got a very popular music streaming website. And all of a sudden you get a song that is very popular and everybody wants to stream that song. And it's very similar to everybody picking up a call to get the song streamed. No one picks up, you get an error, and some people are not happy. Whilst if we say, okay, now we know that we have 10,000 people trying to stream, we need 10,000 replicas of that service. So what we need to understand is, okay, where are these people going to stream from? So also that will help us with the geolocation. Eventually, when we understand more where people are located, where we expect to have the demand coming from, then you need to start thinking about how you're going to balance the loads between those incoming calls and how you're going to start distributing those loads to the pods that you have up and running. I would say there are different spectrums. Like if you go on one spectrum where you say, oh, I'm just going to put everything in one single load balancer and I'm going to have a huge deployment managing all my replicas, it's less overhead, but it's more risk. If that deployment blows, you have no backup.
Yep.
And on the other side,
it's a centralized approach.
Exactly. That's a very centralized approach where it's valid, but do you want to put all the eggs
like
in
a
one
monolith?
basket? Exactly. That's you're dialing back to the monolithic world. On the other spectrum, someone will go, we're in a microservices world. Everything should be. So I'm actually going to have 10,000 pods, and I'm going to put 9,000 services and 9,000 load balancers, and it's like, do you really want to be dealing with that many
overhead?
That much overhead, right? Exactly.
Cool. So one last question: what's going to be the biggest thing that's going to happen with OpenTelemetry, in your opinion, in the next 3 or 5 years?
Wow. That's a good question. I would say one of the most interesting aspects, or this is where I feel like a lot of the vendors that are not necessarily, like the observability vendors are on board, it's more the vendors of the systems. When these vendors start instrumenting their applications natively with OpenTelemetry, it's going to be a game changer, because that means that right now you have users deploying the collector, but the collector has to give the collector instructions about what is the data that you want it to collect, how do you want this data to be processed, where do you want the data to be sent. But if we go to a future world where you have libraries, for example, like the library authors, having telemetry already baked into the library, and you use that library to create applications, or you have a database that has OpenTelemetry natively being exposed, that means that you can just hit an endpoint, get your data, send it somewhere, and that's it. Go to bed.
Sounds good. Thank you so much, Miguel, for
much,
enriching
Ohad.
our knowledge with
Thank you very much.
OpenTelemetry.
Thank you,
so much.
folks.
Hi, welcome to another session of the IaC Podcast, and we have Daniel from Syntasso. Hi, Daniel. Thanks for
Hello,
coming.
good to meet you, thank you.
Yes, tell us a bit about Syntasso and about some open source project that I've heard you have.
Yeah, so at Syntasso, we're the creators of Kratix, which is an open source framework for creating platforms. And the key thing really is about being able to create a relevant API to your business, your goals, and also manage the life cycle of those platform components. So defining platform components with APIs. We use Kubernetes CRDs, as the actual way we deliver it, but we're kind of agnostic to the way you can interact with other things outside of Kubernetes as well. But Kubernetes CRDs control the actual, define the APIs, and then we manage the life cycle, or help people to manage the life cycle of their platform components. I think the key thing that the founders of the company, when they created this open source project, they'd done a lot of work on Cloud Foundry, and they realized that it was amazing for 12-factor apps, but when you went to do other kind of workloads, it didn't really fit. So they've designed Kratix to be very flexible. It's kind of like the Swiss Army knife of platform engineering. That's the kind of pitch.
Got it. So Kratix is an open source, and Syntasso offers a commercial layer on top of it?
Exactly. So we have Syntasso Kratix Enterprise, SKI we call it, which is a commercial offering of Kratix. And Kratix is that open source, Apache 2 licensed, but then if folks want to spend some money getting support, and we integrate with Backstage and Terraform, they can spend some money with us as well.
Got it. Tell us a bit more about the integration with Terraform.
So what we find is a lot of folks using Terraform, it sort of sprawls out over time. So that with Kratix, you can actually sort of build on the modular system with Terraform and treat your platform as a product. I think Terraform, I've coded in Terraform for years, it is a fantastic framework for defining infrastructure as code, but it's not really built with a sort of platform as a product mindset. And I was a Java developer back in the day, and when I had to learn things like Terraform and CrossPlane, suddenly it's new abstractions that I've got to load into my brain. And even though I can define sort of key properties and database size or database name, I still have to look at the Terraform code, I still have to maintain Terraform code. Sometimes, some companies with this more platform as a product focus want to encapsulate that away. So with Kratix, you can, if you choose to, hide Terraform or CrossPlane or Bash or whatever you want to use, abstract it away from the developers. So they are literally interacting with these APIs, these Kubernetes CRDs, and the platform engineers behind the scene can translate those properties, those definitions, into something like Terraform, and they can manage it, and we help them manage the modules and sort of manage the scale of Terraform as well.
It sounds like a core component in your software is Kubernetes, right?
Yes,
why is that?
The founders, when they created Kratix, were really keen not to reinvent the wheel. They loved the API of Kubernetes, they loved the reconciliation of Kubernetes, and they realized that if they were going to build something to support Kratix in the very early stages, 3 years ago, they were going to reinvent Kubernetes. And they were like, hey, doesn't make sense, right? So they built on Kubernetes, and again, we do support, or the project supports other ways of deploying things, but you do need a Kubernetes to run Kratix, if that makes sense.
Definitely. Where do you imagine this kind of KubeCon will be a few years from now?
a few years from now, like, dare I say the buzzwords AI, but like, I think everyone's going to be like, I think we're going to see AI infused like more in the kind of things we do in terms of managing platforms. I think at the moment I'm seeing a lot of co-pilots in things like app dev. A lot of my friends and colleagues are very happy using co-pilot-like tools when they're creating software. But for me, a platform is software, right? We're just defining whether it's OpenTofu, Terraform, CrossPlane, it's all software. I'm not yet seeing AI helping platform engineers in the way I think it could. So I know it's a cliched answer, everyone's saying AI, right? But I do think more and more we'll see Kubernetes abstracted away, and more we'll see AI tooling helping developers, helping platform engineers create the right abstractions to enable then developers just to like code, ship and run. They just want to push stuff and run it, right?
That's great. Thank you so